Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving an equation. We have iz equals 2 times z bar minus I, and we're going to be solving for z values. Great. I'll try to present more than one method. Let's see how we can proceed. Now, for these kinds of equations, most of the time our method is pretty standard. We can replace z with a plus bi, right? That's also a special name because it's the name of the channel. And z bar just becomes the complex conjugate, which is defined as a minus bi. You just negate the imaginary part, okay? Let's go ahead and plug these in. I times a plus bi equals 2 times a minus bi minus another I. Okay, let's go ahead and distribute. ai plus bi squared equals 2a minus 2bi minus I. 2b or not 2b, right? That's the problem. Now, I squared is -1. Hopefully you know that. That's the most important part. And then we get -1 plus ai. I just wanted to write it in standard form. And here we have 2a minus 2b plus 1 as the imaginary part with the minus sign in front times I. Now, when two complex numbers are equal, such as a plus bi and c plus di, what do we know about the equality? We can safely say that a equals c and b equals d. Both of these have to happen because the real parts and the imaginary parts cannot mix. Real is real, imaginary is imaginary. So from here we can safely say that 2a is -1, right? Oh, by the way, it's not -1, I messed up. This is supposed to be -1 times b, which is -b, right? Okay, cool. I'm glad we fixed it. -b is equal to 2a, which kind of means b is equal to -2a. Let's leave it at that. So I got an expression for b. And the imaginary parts, if you set them equal to each other, you're going to get a equals the negative of 2b plus 1. And we can kind of negate both sides and write this as -a equals 2b plus 1. We multiply both sides by negative because I want the b as positive as possible. And b is not positive, by the way, -2a. So let's replace b with -2a. Some people say minus, but I usually say negative. And from here we get the following. -a equals -4a plus 1, which is nice. Add 4a, you get 3a equals 1. And that gives you a equals 1/3. Awesome. How do you find b? Well, b is equal to -2a. If a is 1/3, b is supposed to be -2/3. So we got a and b. We have everything we need. Let's go ahead and write z. Remember, z was a plus bi, right? And we have the values of a and b. A is 1/3, b is -2/3. So this should be our z. 1/3 minus 2/3 I. Now, here's one thing you can do before I start talking about the other method. Let's go ahead and quickly check something. In the original equation, we had iz equals 2z bar minus I. Now, does this equation actually work? Let's plug it in. 1/3 minus 2/3 I is going to give me 1/3 I plus 2/3, because when you multiply I and -i, you're going to get +1. And obviously in standard form, this can be written as 2/3 plus 1/3 I. This is the left-hand side, so I guess you can call it LHS. And what about the right-hand side? This will be, I guess we can do it directly. The right-hand side is going to be 2 times z bar, which is the conjugate of this, which is 1/3 plus 2/3 I, and then minus I. This will be 2/3 plus 4/3 I minus I. That means 3/3 I, or just 1 I. And when you subtract it from 4/3, 4/3 minus 1 is going to be 1/3. And this is going to give you 2/3 plus 1/3 of I. And this would be the right-hand side. Guess what? Right-hand side equals left-hand side. Therefore, our solution checks. Good. And we only got one solution, which means there should be only one solution. Okay, let's go ahead and take a look at the second method, because second method, by the way, second method may not always work, but at least we'll make an attempt. Okay, now here's what I'm going to do. For these kinds of equations, most of the time, this works, maybe all the time, you can conjugate both sides, right? So especially if you have z in terms of z bar or vice versa, this would help because it'll give you another equation. So here's the $1 million question though. If I conjugate both sides like this, right? What about the conjugate of a difference? So can we say that if I have two complex numbers like z and w, is the conjugate of z minus w is the same thing as conjugate of z minus conjugate of w? In other words, what z minus w quantity bar, is that the same thing as z bar minus w bar? And there's actually a really kind of quick way to check it. Replace a z with a plus bi and replace this with c plus di and apply both sides. First of all, let's go and take a look at the difference. It's going to be a minus c plus b minus d times I. This is the difference. I'm going to conjugate it, and that's going to be a minus c minus b minus di. That's the left-hand side again, right? Let's go ahead and do it the same thing on the right-hand side. Here we're going to get a minus bi minus c minus di because I conjugate first and then subtract. This will give me a minus c minus bi plus di, and then I finally can write it as the opposite of b minus d, and yes, they are equal. Awesome, success, which means this is an identity. It's always true. Great. Now, having known that, we can go ahead and proceed as follows. We have iz equals 2z bar minus I. That's one equation. And then I'm going to go ahead and conjugate both sides. But here's the thing. How do you conjugate a product? You can again do the same thing. What is the conjugate of I? You can go ahead and replace it with negative I and z with z bar. And then on the right-hand side, you're going to get 2z because the 2 is not going to be affected because it's real. And then this is going to turn into plus I. Great. So what can we do with this? Kind of isolate z bar or eliminate it. So one thing we can probably do is, I'm thinking about substitution. Maybe that's a good idea. 2z bar is iz plus I, and then z bar can be written as iz plus I divided by 2. Now let's go ahead and substitute this here and see if we can get the z from there. Negative I times iz. So I can factor out an I there. Z plus 1 divided by 2, and that should equal 2 times z, right? And for that, I'm just going to keep it at z plus I. Hopefully this is not going to give me 0 equals 0. Negative I times I is negative I squared, which is positive 1. And now we get the following. Z plus 1 is equal to 4z plus 2i. And then if I isolate z, 3z is going to be 1 minus 2i. And if you divide everything by 3, z is going to be 1/3 minus 2/3 I. And yes, that method is successful. Gave us the same answer. And this brings us to the end of the video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.